Hello everyone. Today I'm going to discuss about fans and blowers. So here we have an industrial plant uses a fan to ventilate its workshop. Under current operating conditions, the fan delivers. So we have a Q of 680 cubic meter per minute. So we have of air, air here. And then at the static pressure, we have 2.54 cm of H2O or water. And while running at 800 RPM. So it consumes 6 kilowatts. Due to increased production, the plant now requires a higher airflow. So due to increased production, we have higher airflow of Q2. So let's say this is Q1 and 1 and 1. So here we have Q2 of 850 meter cube per minute. Okay. Through the same installation as the plant engineer determined the new operating speed of the fan. Okay, so we have A, which is the new operating speed. So N2. So because we have N1. So here, sorry about that. So here we have a shortcut. We have N, then diameter, and then the density. And then we have QHP. Q, H, then P. And we have 1, 2, 3, then 3, 2, 5, and 0, 1, 1. So here, since we're only since we have Q, so we use the Q column, use the Q here, and then since we only have the N, which is the RPM, so we use the N. So here we have Q2, sorry, we have Q2 over Q1 over N2 N1. The ones here, I mean the numbers here, like this, that, and this just mean the exponent. Okay, we have 1 here. Okay, so here we have Q2 of 850 and 680. Then N2, which is the missing one, and N1, which is 800. So we have 1. Then our answer should be, so we have 850, then 680 multiplied by 800. So we have 1000. So we have 1000 RPM. Okay. So next we have B. The resulting static pressure. So PS. We know that the static pressure is 2.54 cm H2O. So the static pressure is what the water would experience if given the pressure, this certain amount of pressure. So what head does the water experience if it is given by this amount of pressure? Okay, so static pressure, or we could rewrite this as head, then we have 2.54 cm of head. We have head here. Okay, so head 2, head 1 is equals to N. Okay, since we only have N here as given, we don't have diameter, we don't have density, so we have N. Okay, so here we have N2 over N1. The exponent should be 2. Okay, since we have 2 here. Okay, so H2, I mean resulting static pressure. So we have H2, then we have H1 of 2.54, then 1000 here, and 800, then squared. So we have H2 of 1800, then squared, then 2.54. So we would have 3.969 cm. Or since we are looking for the static pressure, we would have PS of 3.969 cm of H2O. Okay. Then C. So we have C, the input power required to achieve this increased flow. So the input power, or the P2. So we have power here and the RPM here. So we have P2 over P1. Then we would have N2 over N1. It's number 3 here, so cube. So we have P2, P1 of 6 kilowatts, and then 1800 cube. So we would have P2 of 6, 1800 cube. So we would have 11.719 kilowatts. So yeah, this is pretty much it. So I hope you have learned something, and see you around. Bye bye.